A practical exercise consists also with some preparation, and to check our code coverage, what is tested and what is not. Particularly for Eclipse, we can use ECL-M plugin, and as usual, adding another repository entry, downloading it from there and installing is quite old school. First we can search, is this plugin registered in Eclipse Marketplace or not? It is, so if it is in Marketplace, the easiest thing to install it is using Eclipse Marketplace. And as I can see, it's actually already installed for me. If it's not installed, you can install it. And if you use different IDE, like you can Google it and check how different tools are doing this. For example, IntelliJ IDEA or some other tool. So it is not required, but it will help us. Then other part of preparation is following, that unfortunately to you, this exercise will be much easier if previous exercise is completed, like for activity 13. Because what we have to do here, we have to re-implement manager class for student object in very the same way as for teacher object. So in activity 14 we have another class very similar to the teacher, actually only difference is practically name. And this is actually not very good design, because there shouldn't be duplicated and similar data structures. And if we would design it by ourselves, this probably would be something like person class, and then this person could be related to the courses, like with role like teacher or role like student. But design is given to us, we are not allowed to change it. So we may shamelessly reinvent ourselves or duplicate code in following way. That here in this class you can write everything again, but if we have duplicated design, then we have duplicated implementation, and my recommendation is following, that if teacher manager class is implemented and it works, you shamelessly copy it from one class and paste it for other class. Of course it doesn't compile, but here this package should be changed to 14, and then everywhere where we have teacher we need to replace it with student. And because Java is case sensitive and you have something like teacher, new teacher, we need to find and replace it in case sensitive approach. If it's like class, it should be replaced as a class. And if it's not class, like variable, then it should be replaced like variable. And here I even have some test method here, like in main method, and I can check it out that it actually works. So not in database feature. Which database I am using? I think 00, yeah. What I'm doing here. I'm trying to delete. But let's say 3 and 1. Or 1. It somehow works. If you try to create something, I think it will create. Or to be absolutely sure. I had to pause it here because I created it and I deleted it. And I can't see it from other perspective. So yeah, so it should be working. And of course here I cannot create it with duplicate key 10, but here it was successfully deleted. So that's about this duplicated implementation, but of course this is just preparation, it's not my goal for this particular activity. My goal for this particular activity is to create your own JUnit test. And so we need to create new JUnit test case, which will test these classes in activity 14. And how can we test it? Because we have two classes here, general rule would be that we should have two test cases to test them. One test case tests student class and another test case tests student manager class. But that would be more effort because we would need to create two test cases. And if you want to be more effective, you need to remember about dependencies. For example, here is our student class. And here is student manager. And student manager actually uses student class, so it depends on that class. And when we do different kind of methods here, like insert, find, blah blah blah, update, we actually rely also in implementation of student class that it is correct. on first thing, it's already given to us. Second, when we deal with manager, if something goes wrong, it will not work. My recommendation is always to test only these things which do more integrated testing, and then you test some other classes to which this class depends indirectly. Benefit is that you will have less work to do. Drawback is that if something will go wrong there, you will not be absolutely sure is this problem in this class or is this problem in that class if something goes wrong somewhere here. Because if you would test it independently and you would see that this passes and this doesn't pass, you would know exactly that problem is not here, problem is in this class. If you are not testing this class directly and only that and it doesn't pass, problem might be hiding either in this implementation or that. So that's a drawback. But in times of efficiency, I think you should always rely on actual implementation as much as possible, because when you do test automation, you are mostly interested also about regression. Does it become worse or not? And that means if your set of tests is smaller, but it still tests everything together, then that is fine. And therefore, when we will create this JUnit test case, and we will test student manager directly and student we will test indirectly. So we right click here and say new, and we say JUnit test case, and name is required to be specific. Name should be like this, database unit test 1. And class under test is student manager. And if you like, you can also add setup before class setup, tear down and tear down. If you like, we will use JUnit version 4, and we will test every method for student manager class and finish. So again, if we would be, I will show this later. In general, in proper Maven projects, this database unit test should be under test folder, not in main folder. But these are two different places for source code, either src main or src test. And what is important here is class path, package and name, not location, either in src main, Java or here, for example. It will work in the same way in this folder, the same way in this folder, only difference is how Maven looks on it and how like NetBeans look on it. But I think nobody uses NetBeans here, so we can put it here in incorrect place according to the standards. So we have created this database unit test 1.java test case. And we can run it as a JUnit test. We run it and everything is red here, so nothing passes. And problem is that it's thrown Java long assertion error, not implemented. Not yet implemented. But why it happens here? Because it has these file methods here. And if we replace this with that, so here we see this false negative result. Everything is bad, but this everything is bad actually doesn't mean anything, because as far as I can tell here, from this code and tests, everything should be good. And if we remove this file method and rerun this test again, everything is green. And if that would be some other place and this JUnit test would be written by teacher to test it, then everything should be okay here. But because in this case it's written by yourself, now we switch it from false negative to false positive, because nothing is actually tested here. And therefore what actually will be tested for this activity here is not these results. Of course they should be green, but what will be actually tested is coverage of this package for classes student.java and studentmanager.java. And you can check it visually by running this test in coverage mode. If you install this ECLM plugin for Eclipse, you can run coverage as JUnit test. And then here you have this coverage report, and this coverage report is always shown for entire project, but we are interested in activity 14, and here we see that database unit test1.java is covered at 100%, so it covers itself, so it is executed. But nothing is covered for student.java, nothing is covered for studentmanager.java. And total coverage, including all these three classes, is 4.5. And if we look on these classes here, student manager and student, we see that everything here is some kind of red color, so that means not covered. What is greenish color here, this means it is covered. And how it will be tested automatically? It will be tested automatically from other test, which will call this test, and then we'll check coverage. So we have a test called all tests, which is test suite, which calls test called database test. And this database test uses library called Jacoco, which is Java Kokomo method, where Kokomo is about calculating progress and complexity of the code. If you are interested about Kokomo, you can look on Wikipedia. So it checks coverage, and then this test calls database test1. It executes it, checks coverage, and says what is coverage. And you can test it out, for example, only for this particular thing by commenting out everything else. To make it faster. Oh, not this one, but this one for activity 14. And here it says coverage is 0%. ECL-M plugin and this Jacoco library checks coverage in little bit different ways. And so here is actual coverage, and here is coverage result. And for ECL-M, it counts how many lines of code are covered, and that means as soon as one line of code is covered, this result increases with very small steps. So if I have like 100 lines of code, I will have 100 steps here for ECL-M. But this Jacoco library is not so detailed. It counts covered methods. So here for ECL-M this is covered lines, but for Jacoco it counts methods, and because number of methods is much smaller, then of course it goes up with much bigger steps, depending on how many methods you have. And until some method is fully covered, you see 0, 0, 0, then something more, something more, something more. And of course, initially, if everything is 100%, the result is the same. So, and that would be something like integration test, because we call it from somewhere else. If you want to make it like a JUnit test, you can create entry point, different entry point for this coverage test. You can make your JUnit test case Amphibia or Kentaur or whatever, that it's not only JUnit test, but it is runnable as a Java standalone application. So then if we add main method for it, then instead of this entry point from all tests test suite, from main method you call database tests, which is everything here is in this gtm.jar file. So from your main method, when you start as a Java application, this database test is called. Then of course it checks this coverage and runs your database test as again. So here is as a Java app, it started, but from this database test it is called as a JUnit test, and it checks coverage and it reports this coverage. So then you have another entry point how you can check this coverage, not starting with all tests test suite, but starting with main method of your database test one. So then you can run it as a Java application, not JUnit test. And because now it is considered that you executed this as a Java application, of course this test result is not shown here, because it is hidden. Because what you executed here, you executed Java application, not JUnit test directly. So it's up to you how you want to test incremental progress. You may decide to not test incremental progress at all, But these are these two possibilities. Now about coverage itself. Problem is that we have system with this persistent memory. In this case, our persistent memory is external relational database, where we have some objects put as a records into database table here already. But we will test it and check coverage using CRUD approach, because CRUD is always better because it's more local and we need to not to rely so much on our dataset. And if everything works correctly, of course we will delete everything and this memory what we have here will be untouched. And then, to be constructively lazy, we will not do all these preparations in before class and after class, before and after class methods, but we will do these CRUD operations, create, read, update, delete, in proper sequence. So if we need to prepare, like create record before we update and delete it, we will call creation method before updating and deleting method. So that means that in this particular case, I will not use anything of this. Maybe I will add some before class when I will check how my design evolves. But what I will actually do is following. That first I will force execution order for my methods, which I don't remember how to say, but I have my notes. So we will add this annotation for our test case. And Eclipse cannot resolve imported things here, like fixed method order, method sorter, these classes. But we can add these imports manually also from this example here. And if we do CRUD approach, we will not start with find student. First we will of course start with creation of student manager. And if we say that method order will be executed by name ascending, so this will be executed in alphabetical order. And when we generate code, JUnit version 4 still generates code which, besides annotations, is compatible with JUnit version 3. So naming convention is the test method starts with test. So I will leave it, but first we will run creation of student manager object. Then next will be create. And create part for CRUD is insert and insert in two different ways. And maybe in a little bit different order. Then we will find. Okay, I will update these numbers later. So first thing we need to do is we need reference to student manager object. And remember that for each of these test methods, JUnit test framework creates instance of database unit test. So code is something like this. Database test 1 is, and then it executes like this one. and then it creates completely new object for different method. Something like this. So it will be executed in proper order, but for each of these particular called methods, it will create its own local method, local object, its own method, its own object for these local methods belonging to the objects. And if we have some dependencies here and we need to share information between this object and that object, then of course I cannot create something like int something e here, because this e will be different for test 1 and this e will be different for test 2. So if I need to share information, I need to share them through the static structure, through the variables belonging to the class. And therefore, if I do something like and create student manager instance, then I cannot use it as a local, because then this manager will be different for test 1. So this will have its own proper field and this will have its own field. But if I want to create this instance and use it for other methods, what I do, I add static, because then this means that if something will be done with this student manager object, it belongs to the class, it still will be reused when I refer to it through the other methods. So on here, what I test, I say something like manager is new student manager. And now when I have created it, and even though new instance of database unit test will be created, if this static variable is set up here and I will use it, of course it will use this already prepared variable belonging to the class. And then, if you remember here, when we find student by strings, we actually search for pattern, and to test it properly that searching by pattern is working, we actually need to have at least 2 different students. And I will not rely on this data put here, because that make these tests more fragile, but I will rely a little bit on knowledge of what is in this database. For example, to ensure that when I create my new object with this CRUD approach, that it doesn't overlap with any of these existing ones. And for example, here I see that all these looks like normal names and family names or last names. And if I create object like student, then I hope it will work properly. So I will have again static structure to share these objects between individual methods and individual objects created from JUnit tests out of this class. Maybe 2 students will be enough. And then I can start testing it. For example, I can say that student 1 is And if I look also for methods I need to cover, I know that there are two different constructors for this class: student without parameters and student with parameters. So here I will use constructor with parameters, and again I will rely a little bit on knowledge of this persistent memory. So if I say that ID is something like 100, it should be unique. And let's parameterize also and I will show where this suffix may be. And then I will need to remember also identifiers for these students. Thanks. Syntax errors are simple errors to fix. Logical errors, when you write wrong name for variable, etc., these are hard. And then when this student is created, hopefully this will be unique in our test database. We can say something like manager insert student, student1. And if we are curious, we can run it as a JUnit test. And it is created. So that is one part of creation, and if we run it as a coverage for JUnit test, we see that why this was not covered. Looks like I got some kind of exception. It's console. Strange. Maybe some glitch in this plugin. So I start saying that something is already covered. For example, this constructor for student, which takes parameters. Some of getters are covered, no setters are covered yet. Something from student manager is covered. And if we run it as a Java application, maybe something will be changed also in this overall output using this Jacoco. Test. Well, let's clean up this coverage. I think I run something else. Not so bad. Total test coverage is 31%. You see, work is almost done for me. So, what we do next? We have covered insert student with one particular case, and also that is for manager class, and also for student class to construct this object when parameters are given. In this other method, I will try to cover other set of constructor, which is creation of student object without parameters. And then I will also cover getters and setters. So I covered this already. Now I will try this out. And I will try these setters which were not used in previous test method. Is 9 suffix 2 to make them similar but a little bit different. If you remember about this other method, when we insert student just using strings, we actually do not know what its identifier will be, because this identifier will be given, not this method, this is not in student but in student manager. Insert student, this one. So ID is given to us by database. So what do? We say manager insert student name of maybe I need to add name 2. Let's do something like this. Because too many of string concatenations. And then this becomes much nicer. If we will need to filter it out, we will filter it out when we will do this search by pattern matching by strings. But this looks much nicer. I have introduced more variables, but code is much better. And then of course question is about ID. So here we have some dependencies. We need to find student also. Now, find student by name2. This is list. Because it returns list. When we will be optimist, we will say get zeros out of it, because there should be only one in general. And then for the student to object, we can say set ID is student get ID. And let's rename it just DMP, something like this, to know that it's not very important in long term. Because in long term we just need to know these things. So, and that means we actually also tested a little bit find student, but not very exactly, because we didn't check how long this list is, etc. We just wanted to get back ID given by database. And now, after create, we can do read operations for this CRUD. So this will be 04. We do like by let's say ID 1. And here, to check how it works without any assertion, it's just very stupid. Here we just good coverage, but okay, I will do assertions after that. And here I actually did search already, and maybe I can put this where it belongs. We do search and we also get identifier for this other student as well. So here, because of the dependencies, it's hard to say where exactly this set ID should belong to, but if we know that we are doing CRUD approach, it still follows some kind of same logic here. And then we can test update student, so which student we will change, which is easier to change. I don't know. We still need to remember to which things we do update it. Maybe name 3 or yeah. It becomes quite complicated. Maybe we will simplify it later. But remember, every time you reuse values, also for testing, you blurry this line. And it's harder to debug if you make some logical errors. So initially it's always not so bad that you introduce new values. So we'll say that student 2 is new student with ID 2, but name 3. What was name 3? Yeah, why it doesn't resolve? Maybe because of this compilation error. Yeah. And then if I decided student 2, I update student 2. And now it should have the same ID, but different names here. And we will not test main method for this, and actually I will later remove this one here. Then we can delete both students. ID 1. Delete student ID 2. And manager. Close connection. And I will remove this one to make my, okay, I can leave it and I will show you why should you remove them. And I forgot to update the incremental numbers here. 3, 4, 5, 6, 7, 8. And it will not be called because it doesn't have test annotation for it here. And coverage as JUnit test. So not bad here. The string is not covered. And for manager, you see, for example, mine method is not covered. How we will improve our coverage? We will just remove this method because it's not needed, it was only for testing. Similarly here, how we will improve this coverage? We will remove this method because it was only for different kind of testing. So let's rerun it. Let's check that nothing has changed here. Why these are not deleted? Something is wrong with my logic here, because I think that this should be okay. We will clean up this database manually. And first we will pay attention to the coverage. So for students, we need to use toString method. And for manager, everything is covered except error conditions. So now about things which will not give you any credit, but which is very important, it is assertions. So here, only thing we have checked is that no unexpected exceptions or errors are thrown, but we are not sure that this business logic actually is implemented correctly. So what can we do with assertions? First, we can check, for example, that here, when we find student by this ID, student1 toString is the same as this student. Why it's in italic? And because here we search by ID, we will just write generic error. And student int error. And here we also type toString, of course. Why we need to convert them to string as well? Because we have not implemented on this class equals method. So, and if we will use just check for equality, you know that equals method inherited from Java object means if it's the same object, it is the same, equal. If it's not the same object, even so values are the same, it will not be considered equal. Similarly here, let's do now improve our testing that we will not get zeros here. We will first we'll create list of student also import list from java.util package. And then I compare, for example, that student size, length, whatever, what it is, size, there should be only 2. There should be 2 of them. And it's not zeros. This ID actually should be second one. That was my logical error. And ID 2 should be list, not list students. First. And for debugging purposes, we will print it out. And here again I have that, then I search only for name. So here is this pattern matching. First, if you need to test read operations which returns list of something or collection in general of something, not only single one, you need to have at least 2 of them. And if you are allowed to search for patterns, then here we know that common name, which shouldn't be inside this preset database in persistent memory, is student, but differences between these particular ones is different suffixes. And if I search for common part of these, I should get entire list there. And when I do, and see, I searched only student here, but what I actually wanted to search is student 1 and student 2. And now I still got the wrong result because I didn't clean up my database correctly from previous test. So I clean it up manually from here. And now it even works, and you see now any differences here in database after successfully passed tests. And if we check for coverage, so everything is covered for manager except errors, and everything is covered for student except errors. So we can finish with some assertions here. So I clean it up when I don't want to see these here in coverage tab. remove all sessions. So for updates, what we can check, we have to search it again. Something like manager, find student, and I can search by identifier here, it's easier. And it will return single student. I can convert it to string, and I can assert equals student to string with searched student in database, and of course not in this place, but after I update the student in database. So these are not the greatest possible error messages for assertion error, at least we will know better if something fails, that it's about there. And for deletion, we can delete and we can search for them by ID. So it is actually deleted. For ID1, we need to return what has to be returned if this student was actually not find. With nulls here. So it should be, so what is, let's write out. How does it look like? No. So then we can assert equals so this is not deleted if it's not equal. And similarly, if it's not deleted, then for ID2. And then we can add some of negative tests as well. Depending on how you structure these negative tests may be part of these methods or something else. For example, if it's already deleted, you shouldn't be able to delete it, and if this is called second time, that when you call it second time, it is false. and we need to test it only once. Then we may similarly test that if we create this student again, so here we can do assert that it's true. And if it doesn't work, it is inside student error. And then we may assert false. This should be false, because we shouldn't be able to insert it again, because that is duplicate. Not that. So here, what can we assert to check that it actually works properly is this should return true. And maybe we can actually say where, but we will see, I do not know. And now need to check it twice, because it will always add new students here if you will pass only name and surname with new IDs. So what can we find student ID? Negative test would be something like non-existent ID, and I think it's still no when converted to string. Now let's introduce something like so it always returns student, and still should work. Find student. See here, when I convert it, this is string, but here object is GTM activity student null. So we need to say to string here explicitly. And so here we can also do some negative tests. negative test for pattern matching. Not this. So we will search for Nana where find student. Oops, not that. Wrong name. And it should return, let's say convert it. Maybe because we have compilation error here. Wrong name should be twice. And I do not know. So it should look like following empty list. And now when I fail, still nothing is added here. That's good. And similarly for update student we may add negative tests like update student, let's say wrong ID. Wrong name, wrong name. One, two, three, one, two, three brackets. So we shouldn't be update this student, and if you like we can also say this is negative test. And we can put this negative test at the end if we like to group them. And I do not know what happens if we close connection again. Maybe we will not do a negative test for this as well. So that's about this particular exercise. Now I will just mention these things. When you check your coverage here, you see that one thing what is not covered is catching exception and printing stack trace, so that decreases your total coverage for this activity. One very bad thing what you can do is, for example, run it from here to see also coverage. It still rounds up to 10 out of 10. That's then great. But if you look precise number here, coverage is 91%. But if everything is green, we can live with this. But if something was not green, for example, it was a little bit below 90%, like 80 something, we can just eat up these exceptions, doing nothing. Rerun this test again. And now it's 94. What is missing here? I probably didn't. Oh yeah, so here timed out exception. Let's run it again. I need to remember to delete this one, which prints out it's not needed anymore. Okay, so improved a little bit, but this would be very bad thing to do, because even though your metric, like your coverage, is improved, your actual implementation is worse, because you are eating up errors saying nothing. Proper way how to deal with this is, you cannot get easily these SQL exceptions, because if it's implemented properly you will not have these wrong syntax here, etc. You need actually somehow break MySQL server to get it. And if you would do this, that would be quite complicated and heavy integration test, not JUnit test. If you want to make it like a unit test, you need to have these stub objects. And for example, here you introduce like test. Actually, that would be before. But we can actually do it completely separately. Test exceptions. Again, we can remove that one to improve our coverage. And here we need to add these stubs, because I do not do it every day. Here is like proof of concept, how can we do it. So here we will also import static. Where is import static? All these fields. Mockito we will import static everything. No, it doesn't. Objects. That should do. Why it doesn't? No, other imports. And surround with catch. And this also should be. So, what I have done here, okay, I can make it a little bit shorter. For example, just to commit transactions. So instead of normal connection, I have created Mockit connection. And I set this Mockit connection instead of normal connection for this manager object at the end. And when so why particularly for commit? Because when you need to mock something up, you need to get this common place where you can throw error for different things. And if you look, for example, for this manager, if you use transactions, you can get, for example, this exception case here. Every time you commit transaction, unfortunately not for all methods, like for find, we for other reasons removed them. And it works in the following way, that when this commit method is called for this Mockit connection, so that means when commit is called, because we have mocked up or broke this connection object, it will throw this declared Mockit commit exception here. And when we run it as a JUnit test, we see here at the end, Mockit commit exception was thrown here. And if we try to run it with coverage now, and go to insert student string, where is insert student string find? Maybe it's easier to find it here. See that this part is also covered as well. And this is how, so what you do here, on just fail. And you may, for example, assert something like assert equals get message is this particular message here. something like this. And when we try to run it, strange. Oh, that is a little bit strange. Okay, we will remove that fail here and check that at least this catched exception is correct. And so we got something like this. That I don't know why it... I know why it happened. Because here this exception is eaten up in insert student. You see that it actually do not allow to throw it outside this method. This exception is caught and just printed out here, so I cannot write for exception inside test here because it is caught and handled. And by handling I mean just printed out on standard error output here in this insert student. So again, my logic was wrong. So it is eaten up. In this, but why we can catch it here in test? That's... because this exception is not caught, this actually is not executed. So then here we actually need to do something like, if we got here unexpected exception, we can say false. This is unexpected exception. That's how this should look properly, because this mocked exception is created and caught inside insert student method, and it doesn't come out of this method. But if we look here in stack trace, we should see that somewhere here at the end, here is this mocked commit exception was created and printed out, because that's what we do here in this method. So that's just touching and introducing mocking up objects and how you can get full 100% coverage if you need to get it somewhere. So, any questions or comments?